this kind of automatic changeover switch, because this is single phase automatic changeover switch that can be used to switch between two different power supplies using two contactors and one piece of pin relay. It can be 8-pin relay, it can be 11-pin relay. So it depends on the pin relay we are using. Check the diagram of the pin relay. Make sure that the pin relay have at least two commons so that you can use it to interlock whatever you want to interlock. How does this one work? One contactor should be used for utility supply, which is NEPA, and one contactor should be used for generator supply or inverter supply. In a way that when generator is working, it means that there is no utility supply, NEPA is not working, and when there is NEPA, it means that the generator have to stop working. So the generator will not work when NEPA is available, and when there is no NEPA, it means that generator can work. So the work of the pin relay is to interlock this in a way that two of them cannot collide together. So what we do, we use two contactors. If this is one contactor, follow me as I draw. If this is one contactor here, I draw this way so that everybody will understand it clearly. If this is another contactor, let's say that this is one contactor and this is another contactor. Now, if this is one contactor, we have one, let's say, is single phase, so we can just use 3 pole contactors for this. This is 3 phase. This is a single phase, sorry. So if we have L1, L2, L3, the output is T1, T2, T3. And we will have L1, L2, L3 for this contactor. The output is T1, T2, T3. And when we want to see that they are normally open terminals. So they are normally open terminals. The L1 is normally open to T1, and the L2 is normally open to T2, as well as L3 is normally open to T3, because the input is L and the output T. So if these are normally open terminals, it means that current can never flow except if the contactor is energized. So if we use this one as maybe NEPA contactor, and we use this one as maybe generator contactor, and maybe if we have this as our DB of the building, which require input, maybe single phase DB of the building, live and neutral, and maybe have this neutral point and this breakers, just DB, normal DB. So if we have this as maybe DB of the building here, DB of building. So if you have this as DB of the building, then we can use this L1 and L2 as live and neutral of NEPA supply. NEPA supply, which is 220 volts here in Nigeria, and we use this contactor as live and neutral of what? Generator supply, which is again for inverter supply. So if we have this way, it means that we have two different inputs, but their output should be one because they are powering the same DB. So T1 connects to T1, T2 connects to what? T2. And that's what gives you output to this DB. This means they are not joined together. So we connect this, means that when NEPA is supplying this, when generator is supplying this. But the two contactors should never work the same time. So it means that one contactor can only work. Are we good? So when this contactor is working, this one can never work. And when this one is working, it means that this one can never work. Yeah. It means that two of them, one will be primary, one will be secondary. The primary will be the one controlling the secondary. But then, since we don't have access to NEPA, utility supply, we don't know when they will bring NEPA, we don't know when they will take NEPA. That's the reason why we use this as primary and we use this as what? Secondary. So that when NEPA brings light, if you're on generator, it will automatically take over from generator. To achieve that, we have pin relay. So we are going to use pin relay base. So if this is pin relay base here, and on the base of pin relay, according to what we did yesterday, we said that we have coil terminal, according to terminal categories of pin relay. We have coil terminal, we saw that yesterday. If this is the coil terminal of this pin relay here, with coil symbol, we also have normally open terminal because one terminal must be on normally open and one terminal must be on normally closed. So we have normally open and have normally closed. So if this is normally open and this is normally closed. Let's say on pin relay that we are using, this is 2, 7 as the coil, 1 and 3 as normally open, which 1 is common. 8 and 5 as normally closed, which 8 is what? Common. So what do we do? If this is the coil of never contactor here, this is the coil of never contactor here, and this is the coil of generator contactor here. This is the coil of generator contactor here. Simple. Live wire will have to travel to terminal number 2 of the pin relay. Then neutral wire have to travel down to coil of the contactor as well as the other coil of the pin relay in order to do what? Energize the pin relay. So what remains is this live wire to complete it. This is A2 of this contactor coil, and this is A1 of this contactor coil. Neutral have already gone to A2, remain live wire to complete it. So we can tap supply from this 2 to what? 1. Sometimes we can connect it from here because it's same live wire. Because if you don't supply current to the common, there won't be output according to what we saw yesterday. So the output of this one is what? 3. So 3 have to go to what? A1. Then you see that generator doesn't need any coil to energize on pin relay because generator will just pass as normally closed. So in this case, live wire from generator supply goes to 8, and then 5 comes to what? A1. This is A1, and then neutral supply from generator we then have to pass through what? A2. So this is coil of never contactor, and this is coil of generator contactor. Generator is not a contactor anyway, you're using it. And this is pin relay. This. And then these are contactor 1, this is contactor 2, and we have finished labeling them. This is normally open NO, this is normally closed NC. So the primary supply, we are using this NEPA as primary, and we are using this generator as what? Secondary. So primary controls what? Secondary. So this is how we did this diagram of single phase automatic changeovers with using 2 contactors and 1 piece of pin relay. Thank you very much.